Predicting concrete durability with machine learning. Predicting the durability of concrete under different environmental conditions is a challenging task as- that requires understanding of both material science and machine learning techniques. Various machine learning models can be used to predict concrete durability, which typically involves predicting factors like compressive strength, resistance to environmental degradation, example freeze thaw, cycles, and sulfate attack, and long-term performance in different weather conditions. Introduction and the challenges of the concrete degradation. Concrete degradation is a significant challenge in the construction industry as it directly affects the long-term performance and durability in concrete structures. Concrete is often exposed to various environmental conditions, chemical reactions, mechanical stresses, and biological factors that can lead to degradation over time. The challenge lies in understanding the mechanisms of degradation, predicting its progression, and designing concrete to withstand these as as long as possible. Like there are some key challenges are like uh, environmental exposure, chemical reactions, mechanical stresses and fatigue, the corrosion and reinforcement, and environmental and climate change impacts, and the lack of predictive models for long-term durability, etc. Next one, environmental factors and concrete properties. The environmental factors and concrete properties are deeply interconnected when it comes to the durability of concrete. We can think of concrete like a sponge. It's porous, so it interacts with its surroundings. The environmental factors act like the elements of weather, and the concrete properties determine how to handle those elements. Environmental factors plays a significant role in determining the long-term durability and the performance of concrete. These factors such as temperature, humidity, exposure to chemicals, and mechanical stresses interact with the concrete material properties in complex way of in complex ways, often accelerating degradation process. Like environmental factors that impact on concrete durability are like temperature, and freeze thaw cycle, moisture and humidity, salts like chlorides and sulfate exposure, and properties there are some properties which plays a crucial role in concrete durability like water cement ratio, the porosity, mixed design, type of cement and additives, reinforcement like steel, etc. Next one, model selection and exploring the regression algorithm. Regression algorithms are a class of machine learning models used to predict continuous outcomes based on one or more input features like predictors. They are widely used in scenarios where the goal is to model the relationship between variables and make predictions. Common applications including predicting house prices, forecasting stock market prices, or estimating the durability of concrete under various conditions. Uh, and we will explore some popular regression algorithms and highlighting their characteristics like regression. Linear regression is one of the simplest and most commonly used regression algorithms. It models the relationship between a dependent variable output and one more independent variables inputs by fitting a straight line in 2D or a hyperline in higher dimensions to the data, where Second one, polynomial regression. Polynomial regression is an extension of linear regression that models the relationship between the dependent variable and the independent variables as nth degree polynomial. The third one, ridge regression. Ridge regression is a form of linear regression that includes an L2 regularization term. It adds an penalty to the regression coefficients, which helps to prevent overfitting by shrinking the coefficients, especially in high dimensional datasets with multicollinearity, high correlation between features. Fourth one, lasso regression. Lasso, least absolute shrinkage and selection operator regression is similarly to ridge regression but loses L1 regularization. It adds a penalty equal to the absolute value of the coefficients, which can lead to space model where some coefficients are exactly zero. This helps with feature selection by automatically eliminating irrelevant features. Fifth one, elastic net regression. Elastic net is a combination of both ridge and lasso regression, incorporating both L1 and L2 regularizations terms. It is particularly useful where there are many correlated features, as it can handle both feature selection and coefficient of H. Next one, gradient boosting regression. Gradient boosting is an ensemble learning technique that builds trees sequentially where each new tree attempts to correct the errors of the previous one. It combines weak learners like decision trees to form a strong predictive models. The next one, identifying key predictors of durability. Identifying key predictors of durability under different environmental conditions is a crucial task in ensuring the longevity and performance and concrete structures. Now, durability refers to the ability to concrete to resist environmental influences like moisture, temperature, chemical exposure, and physical wear without significant degradation over time. And there are some various factors influence concrete durability, and identifying the key predictors involve considering the interactions between material properties and environmental exposure, like water to cement that ratio is fundamental parameter that affects concrete porosity, permeability, and strength. Second one, cement type composition. The type of cement used and the incorporation of supplementary cementitious materials such as fly ash, slag, or silica fume can significantly influence the concrete resistance to various environmental stresses. Third one, aggregate type and quality. Aggregates make up a long portion of concrete by volume, and their type, size, and quality directly influence concrete strength and durability. Fifth one, and etc. The key predictors of concrete durability are interrelated and depend on the concrete mixture, environmental exposure, and maintenance practices. Engineers must take a comprehensive approach to optimize these factors to specific conditions and ensuring concrete structures remain functional and safe over time through appropriate material selections, design practices, and environmental awareness. Concrete can be made more durable and resilient against degradation over its service life. Results and discussion, model performance and insights. There we can see the 90% of chloride resistance is accuracy, and freestyle or damage prediction accuracy is up to 88%, and the key predictors of environmental are 5, and these models effectively highlighted in critical factors influencing the concrete durability. Conclusion: understanding and predicting concrete durability under various environmental conditions is essential to ensure the long-term performance and safety of concrete structures. The key predictors of concrete durability include factors such as water cement ratio, cement type and composition, aggregate quality, air content, and curing conditions, among others. Additionally, environmental exposures like freeze-thaw loss cycles, chemical attacks, fluorides, like chemical attacks like chlorides, sulfates, acids, and alkali silica reactions plays a significant role in determining how concrete will degrade over time. As the construction industry continues to evolve, understanding the interplay between concrete properties and environmental factors will remain a critical area of research and innovation. By leveraging these insights, we can develop more resilient and sustainable infrastructure capable of withstanding the challenges posed by both natural and man-made environmental factors. Thank you.